like we are live. All right. All right, so I think we go ahead and get started.
I was gonna say if I make this, I get an A.
What's that?
I'll say if I make it, I get an A.
Not doing that. But you're gonna miss. This is a pressure. It was a pressure on me. All right, so those. I think we had some people that were, I don't know, maybe possibly watching it on YouTube. Power went out on us. Just kind of completely shut everything down. I don't know about you, but I opened up my R and this is where I left off. I mean, it kept it in memory. I don't think it got everything in that data function, but I was working on it. So just gonna kind of try to pick up where we left off here. So, we were gonna load the Dune package. And I'm gonna tell you that I can't quite remember this actual function of how to use it. All right, and I know we'll get to how to find the help file. There's a trick with this is that one of them has to be in parentheses. And I think it's the package name that needs to be in parentheses. So what we're going to do is run this just to see if it works. And if not, maybe we'll get an error message. Nope. No error message. It loads it in memory. I can see it here. All right. So we loaded it. Then the other part of that question was to list the variables within the data frame data. All right. So I can ask you, what are the variable names in data? And there's several different ways to do it. One of them is with the names function. All right, so what does the names function do? What I'm going to do is make sure that I have the actual capitalization. So names is all lowercase. So the names function lists the names of the variables in a data set or a data frame. Just exactly what it does. Okay? That's its role. So, chunk. If I do names Dune, and I can reference Dune because it's now in memory. I put it in memory once I issued that data function, that data command. All right, so I've got names Dune, and when I run it, it gives me the names of all of the variables. How useful is names? I think it's pretty useful. We'll see. Hold on. Those of you on the ASU computers, when the power went out, did it save?
No.
Absolutely no. Figures. Okay, so I think what we'll do is when I get to the end of today's, I think what I'll do is I'll save this RMD file and get it posted on Blackboard. So you don't have to go back and recreate it. You can kind of copy and paste what you don't have. All right? We'll help you out. I think I did that last time. But all right, so the names function, I use it a lot, so I can see the actual names of the data frame. And I don't necessarily use it in my markdown. I actually use it in the console. So you can see that what this markdown is doing, what this chunk does, is copy and paste the function down here, and then it takes the output and pastes it back up into the markdown. So what I often like to do is issue the names function down here so that I know what variable names I'm working with as I create my statistical models to try to analyze the data and so forth. Yep.
Mine was going to be different.
What does yours look like?
I have 1, 6, 11, 16, 21, 26. I'm counting all of those.
Right there, right? Oh, the number. Okay, so the numbers. The difference was the numbers. The difference was the numbers, not the names. So, all right. Let me redo that. Let's see if I can rerun that. We can have my numbers changed again.
Okay.
So these numbers, again, just reference, they just give me what number that is in the data set. So for the names function, it gives us all of the names of the variables. The first column is this, octomil, a shamil, something like that. The 25th column is that one. The 29th is that one. This is the 30th. So I know that in this data set, I have 30 columns in this data set. All right. And we'll go over, I'll show you how we can figure out what these names actually are, what they mean. But I use the names function to do this. Are there other ways? Oh yeah, there's other ways. Let's go over to this environment window. The data frame has an arrow right here. If I click on that arrow, it drops down all of the columns that are in that data set, all of the variables that are in that data set, all 30. So, if I ask you, hey, name the columns of this data set, there's several different ways to arrive at that answer. I could use the names function, I could do the drop down, or I can even type in the Dune data set. We did names, right? If I inserted another chunk, and this is just for demonstration, I'm not going to use it, and I run it, it gives me my actual data set. And those are the variable names. I would have to go in and hit the next to go see what the next ones are, and I'm basically getting 1 to 5 of 30 columns. I have to use these arrows to kind of cycle through all of our columns. So there's ways to get it, different ways to get at the same answer. All right. Move this out of the way. All right, so that's working with data frames that are in R, and we will use some. We'll use some data sets. Use them because they provide the help files with them. So if you didn't have your notes, you can go to the help file, and the help file did a lot of the same stuff that we do. So you can find those answers. Now what I'm going to show you how to do is read in data that was given to you or that you generated yourself from Excel. All right. So we're going to import data by clicking on buttons. All right, and this is where RStudio really becomes easy. So, up here in RStudio, we have an import dataset button right here. When we hit import dataset, we have a lot of options. We can import from text, which is part of the base package. We can import from text using the reader package. We could import text from Excel. We can import files from SPSS, from SAS, from Stata. And there's additional packages that increase functionality, increase the type of files that you can import. All right? What we're going to use is import text from the base function. That's what we're going to do. And when I click on that import from text base, it opens up my document window. because now it says, okay, what file do you want to import? And then I just go through and find the file that I saved and click on it, and then that'll open up a new window. So what we're going to do is we're going to use daphnia.txt as an example. And I'm going to walk you through how to open up this file. All right, this file is on Blackboard. So what we're going to have to do is you're going to have to go to Blackboard and get logged in. Here's my Blackboard. Oh, which, by the way, I don't know if you guys were aware of this. Go to ASU's website. ASU has this, coronavirus updates. I don't know if you noticed. They update the reported cases. So how many do you think's on campus? Active? Who looked it up?
Oh, I check every day. I looked it up today.
Yeah, 18 total cases right now. We had no idea. I kept waiting for the news media to report how many cases were at ASU. And then I found out, oh, it's actually posted online. So it's pretty cool if you're interested. That's where you find it. Anyways, all right, so we're going to be in biometry. Now, as I said, anytime we have data sets, especially as it's part of our lectures, I will have it included. I will have the text files included. Even if we do use the same text file a couple times, I will repost it. All right, so the ones that we're interested in are daphnia.txt and glyco.csv. All right, so we're going to start with daphnia.txt. If I click it, it opens this up. And that's not what I want. Because if I try to save it, it's gonna save it in some weird format that's really gonna screw things up. All right. So what you're gonna have to do is right-click the file. So go back to here. When you get your cursor over daphnia.txt, you'll right-click it and then save the link as. All right. I don't know how it's different on your guys'.
In our case, I think it's download link file.
Download link file as for the Macs. All right, so I click on this, and then I'm going to go to my data folder. So remember when I set it up, we kind of have our biometry class. I've got my presentations, then I have my R folder, and then I have a data folder. And I like to put all my data files together. All right, I like to put all my data files together. So what I do is get to that folder, and then once I'm in the folder, I make sure that it's called Daphnia. All right, just keep the defaults, and then I hit save. All right, so I already have it in there. I'm not going to hit save, but you would hit save, and then it downloads the file right to your computer. Now we can check it. So here's my window. I've got R. Yeah, I'm in my data file. There's my Daphnia my Daphnia file. I'm going to open it with Notepad. Where it is? Here's my Notepad. And it opens up this file. It looks a lot like a data file. It's got columns. All right, it's got names at the top of the columns. It's got rows of data across it. All right, so I've downloaded it as, a Word document or as a text document here. All right, so things are looking pretty good. So now what I'm going to do is go back to my R Markdown, or my R Studio. All right. And I'm going to go back to import data set, and I'm going to say I'm importing it from a text using the base function. The base function is important. If we use reader, it imports it as a different type of object, and it will conflict with some of the scripts that we work with in the future. All right, I've produced some scripts that rely on data frames. We'll get errors if we don't use the base function, or we have. So I click text. from text base, and then I go to my folder, our data. I go to my Daphnia file. All right, it's highlighted. You can double click it to open it, and then I hit open. This is my fault. R code execution error. Let me close this out. Oh man, the windows. Let me move this over. I'm zoomed in too much. All right, let me do this over. I zoomed out just a little bit. Import data set from text base. I have to go to my network drive, and then do this 5 steps. You shouldn't have to do this, but I know I do. There. All right, now I open it. Now I get my window. This is the window that we want. So R has gotten much, much better at figuring out how the data file is structured. So it's going to open up the text file. It's going to try to figure out what your delimiter is. And your delimiter is what identifies the different columns. All right? So we can have a comma, we can have a semicolon, we can have a space, we can have a tab key. All of that stuff gets encoded or gets saved in the text file itself. R looks and tries to deduce what that separator is and puts it into the file. So it sees this input file, that input file right at the top. That's what it sees. And then it says, okay, based on what I see, I think our separator is a tab key because that's the encoding that's in the file. All right. I think that your decimals are periods. All right. And, you know, we don't have any double quotes or anything, but I think this is all the information that I have. So if I read this into memory, this is what it's going to look like right down here. So we look at the data file and we say, okay, well, I've got growth rate. I have water, detergent, Daphnia, meaning the clone. All right. This looks like it's correct. I'm telling you that this looks correct because I created the file and I gave it to you. So it looks good. Before we do anything with it, we might have to give it a name. All right? I'm going to leave the name, I believe, as Daphnia. Yep, I say read it as Daphnia. So I'm going to, I say this name, we have to look at it. It's because if you don't say anything, if you don't change it, it's going to save it as the file name itself. And sometimes you may be in the process of saving new files, you know, with a different date every time you work with it. Well, I don't think you want a data frame name to be 20 or 26 characters long. So you can make it simpler. You could say data, all right? Or call it, you know, Daphnia, like I do. So the name's set. I'm going to hit the import function, all right? And then it's going to import the data set. And it imports it right as a data frame into memory. So here you can see in our global environment, Daphnia is now present. It's there. It's accessible. All right, I drop it down. I can see my variables. They're there. All right, our studio also opens up this data frame. Now, I think all of yours will. All right, this is an option. We can kind of suppress that output if we didn't want it to always open up like this. Do we need it? No, not really. I'm just going to close that. All right. So we have it, but that's not the end of it. All right. And that's not the end. We're not done yet. All right. Because what we've done is used the menus to import this data frame into an object that we can then reference. If we were to create a markdown document, if we were to knit our document and make the word, R doesn't know what we did. So it's going to complain anytime we try to reference Daphnia. And not just complain, it'll stop. It'll say, I have an error. I don't know where this thing is found. All right. So what we're going to have to do with our external data sets is take the actual code that R used to import it and get that transferred into our markdown document. So every time we run the markdown document, it automatically imports that data set. All right. So I'm going to make a note here that says we use the import data set from text base button to read data into R. But so if we do not copy and paste it, whoops, the init function. Emphasize that it will fail spectacularly, and you will be left with, oh my goodness, how do I create it? And on an exam day, you'll be sitting there saying, I have a deadline, I have to get it in by 4, and it's failing, I don't know what to do. And then you call me over and I say, well, where's your data? It's in here, I can see it. And I said, okay, where's the code that does the data? And then you go, oh crap. Then how do we do that? Very easy. You just go down to your console window, because that is the code that R used. I'm going to highlight that. All right. You can right-click and copy, or Control-C, which Max might be what? Option-C for copy.
I don't know, all right.
All right, for your keyboard shortcut. And then I go back into the chunk and paste it, and it is now there. All right, it is there. So now, every time I open up this markdown document to work with it, and I need to load the Daphnia dataset, I don't have to go through the buttons. This is the code. I run the chunk, Daphnia now becomes accessible. So with the markdown, when this knits, it goes chunk by chunk by chunk, gets to this line, it reads the data, Daphnia dataset into memory, and now Daphnia is accessible. All right. You will see that this function, we are reading a delimited file. The tab delimited file, that's our default. And then it gives us the exact location of the file in the file system itself. If you knew this, you could easily write it yourself. And if we were working with just the R console, we would have to know that location. Now, fortunately, R is pretty good about auto-filling, finding the documents and then using tab to autocomplete, the different locations. But, not everything is easy. So when you import the data set, you have to copy the code, get it into RStudio to make it work. All right? So I'm going to save this. We know Daphnia is present. We know Dune is present. What I'm going to do is clear memory. So now it's no longer there. If I typed in Dune, I get an error message. Now I can show you that if I run that chunk, Daphnia is back in memory. So it's very easy. Once we get it in, very easy to keep it there. Did everyone import it? All right. So you see the console window. Ours is all going to be different, just kind of depends on where it's saved at. I put this because when I'm working on my own computer, I've got this in my Dropbox file, and I've got this little squiggly means your home folder, all right? And I believe it's the same in Windows. So what I can do is, if I set up all of my computers where I have my home folder and then the Dropbox folder and everything, I can easily switch computers, and all of the code still works. All my files import correctly, they load correctly. It just makes things a little bit easy to use. All right, so RStudio does a good job at auto figuring out what the file format is. So there's very few times that you're going to have to adjust anything. But sometimes you might have to, all right? You might have to. And that's where it benefits you to look at the actual window itself to make sure that the data file looks like it's a data file. Separate column for every variable, individual rows. Here. All right, so practice glyco.csv. All right, that's posted on Blackboard. All right, what I want you to do is import glycogen, that glyco file. I want you to save it, to call it glycogen. All right, I want you to call it the glycogen data set. All right, and then what I want you to do is determine the names of the variables that are in that file, in that data frame. And don't forget, make sure you copy and paste the code into an R chunk. Yep.
In the environment, is there a way to just delete one, or do you have to tear it all out?
In the environment.
So like if I just wanted to delete that and not everything, or had you everybody?
There is a way to do it, but not. You have to go down.
It's too complicated.
Not really. So you just have to go down here. You know what it's called? RM is the remove function.
Okay.
So if you do RM Daphnia and run it, it takes that one out.
Okay. That's easy enough.
Oh. All right. Did you get it in? What are the names of the glycogen variables? Did you get it?
We've got the control, compound 217, compound 217, sugar,
Is that the column name?
or
Treat. All right. Rat, prep, read, glyco. All right. So, demonstrate. Yep, I did. Get this. There. Increase the size a little bit. All right, so yeah, same process. I read the glyco.csv dataset into R. I used the buttons, the import dataset, buttons. I did from text base. R was very good at identifying the delimiter and opening the file. Now, I did change what the data name was, so I changed it to glycogen. And then when I ran it, I saw that it worked. I copied and pasted that code that was down in the console. So glycogen, the read.csv, copied and pasted it. Now you'll see that instead of read.lim, it was read.csv. All right. The default function or the base function is read.table. That's the base function. But they have more specific functions where read.delim uses white space as a delimiter. Read.csv uses a comma as a delimiter. All right. But it's there. And then you can check the variable names by either using the names function, or you can drop down and check out the names that way. All right? All right. So what about this from text reader? Our studio started out, we started using class before it hit its major version number, version 1. All right? Once it hit version 1, it actually introduced this reader package where if you read in a data set, it calls it a Tibble data frame. Now, they say that it's easier to work with these types of data frames. I don't know if they are. I don't use them. All right, you can, and I'll leave that to you. You can Google Tibble data frame. Some data science people say that it's more useful to work with them. But from our perspective, we're not really data scientists, all right? So a lot of our scripts, a lot of the functions that you find online are going to reference data sets themselves or data frames. So if we use this reader package, then anything that calls a data frame is going to fail because the object isn't technically a data frame. It's this Tibble object that then has several different categories inside of it. And that's going to be a problem. So, just to kind of demonstrate a little bit of the structures, there is a function in R that allows us to look at functions in our data, and objects. So I'm going to do this, run that, and run even nums. All right, so there's a function called structure, str. And if I did str of x, it tells me the structure of my object. It's a numeric object. The value is 3. It's a lot like what we would see up in the environment window. If I do structure even nums, it tells me it's a numeric vector, items 1 to 6, and it gives me the items. It's all great. If I do a structure of a data frame, so Daphnia, it tells me that I'm working with a data.frame. And that's important because a lot of our functions, like a t-test or an ANOVA, one of the error capture statements early on in that code is to check to make sure that we're working with the data frame. If we're not working with the data frame, that function stops and returns an error. So if you do this from text base, we shouldn't ever run into those problems, at least in this class. So I strongly suggest, no matter what you do, always use that from text to base when doing the import data set. Now, when they went to version 1.0, they had that, really threw a lot of things off, and there was an outcry, and they basically came out, they put that back in fairly quickly. I think it only lasted maybe about a month, but it was enough to really screw things up. All right, so continuing on. Now, we're working with the data frame. The data frames have variables inside of them. The variables have their own data set. We've shown you how to take your objects, your data points, create vectors, and then we showed you how to take the vectors and combine them into a data frame. Now the question is, how do we access all of that information that's now in a data frame? We do that by referencing those variables using their name. All right? So, if you typed in Z, you may get an output. You may get an object not found. All right? So go ahead. You can do that just as a check. And I'll show you mine. So if I just go, if I just type in Z, I know there's nothing in memory. So I get an object Z is not found. Yours may return 8 if you ran the entire R Markdown document. All right. The same thing's going to happen with data sets. So what I want you to do is type in women and tell me what we get. Tell me what gets output.
Height and weight table.
Do we get the height and weight data frame, right? All right, so height's in there. Go ahead and type height. Let's see if we can get those vector of heights out. What do we get? What do we get? Error. What's the error? Object not found. What do you mean object's not found? Isn't it in the women data set? It's there. We can see it, right? Yeah, we can see it. How do we access it? What's that? The number sign. Number sign. All right, so let me get this in here so we can start. So I did. So I said reference. So I'm going to do a new header. So referencing data in a data frame. This could also be referencing data in a matrix. Referencing data in a data array. All of it's very similar. All right. For us, we're going to start with our data frame. So we view the data frames by typing their name. We typed women. We get to view it. All right. Now we see that women is or height is one of the variables. All right, but if we type and run height, R tells us that object can't be found. So object. All right, so how do we access the height variable? We're going to do so using the data $ variable format, where data is the data frame name and variable is the variable name or the column name. All right, so we're going to do this by the data $ variable format. So if we wanted to access the height, all right, our data frame is women. That's our data. $, and when I hit the $, now RStudio pops up and says, okay, inside that data frame, this is what I have. And you can start typing it out, or it's highlighted. So I'm going to hit the tab key to auto-complete it. And now when I run that chunk, it returns all of the data that it's in height. Now that height is a vector inside of a data frame. So when we reference it using that $, it returns a vector of numbers. Exactly what we want. All right, so we did that. Okay. So we have this format, data $ variable. And the $ basically says, hey, this is a variable name. All right? It's not the only one. It's in some of these programming languages. The $, says this is a variable name. Depending on the programming language, it may be a different symbol that references that. But that's our basic format. So we viewed the height variables in women. You can do the same with the weight and see the weight variable. All right? So you can do that. And you could do that in the same chunk if you wanted to. So you didn't have separate chunks. All right. And once you've confirmed that, now view the glyco variable that is in our glycogen data set. See if you can do that. Did it work? So I do have this up here. What happens if we get error, object glycogen not found? Yeah, okay, so number one, it may be that we didn't read it into memory. So it's one of these things where possibly we saved the file, we open it up at a later time, and when we run it, we get the error. That's entirely possible. What else? Did anyone get this error message? Don't be ashamed if you did. Anybody?
Rename it like.
Yeah, so the other thing is maybe you actually called your data set glycogen with a capital G. And then when you reference it, you use glycogen with a lowercase g. That's problematic. All right? R requires capitalization. Capitalization matters, spacing does not. All right? So if you use the capital, you have to keep with the capital. If you use lowercase, you have to keep with the lowercase. That's why I use all capital here. All right? If you didn't use all capitals, it would fail. It can't find that. All right? So what I did was went back, and in my data set, so just a little bit more to clarify. So this example returns a height and weight vectors. So I got women height, women weight. All right, and then I have my practice where we view the glyco variable in this glycogen data frame, and I get all those numbers. That works. And just to demonstrate, perhaps I screwed up and used a capital G in my code. If I run it, I get object glycogen not found. And you're going to say, "What? I read it in there. It's there. I see it. Here it is." You're going to call me over and say, "Yeah, that's there." But glycogen with a capital G is not. And you're going to say, "Oh, crap." You're going to fix it. So glycogen with the lowercase g, $glyco. How we reference our variables. All right, so if we were interested in calculating the average, the mean of, let's say, height in that women variable, what we can do is calculate the mean of this entire function. So R takes the data set, pulls out the height vector, and then from that vector applies the mean function to it to make things work. Questions? Let's move on. All right, so important tips. R is a command line driven program. It's based on Unix. It's based on the Unix operating system. That means spelling matters. Women versus woman. Woman. All right? Singular versus plural. That matters. These are two different variables. Capitalization matters. Lowercase versus uppercase. Those are two different variables. All right? Women height versus women height. Again, note the capitalization difference. Those are two different things. And then the mean is the average. Yeah, lowercase mean versus uppercase. Uppercase is going to fail. There is no function with an uppercase mean, but a lowercase mean will work. All right? Now, because it's in a Unix-based system, most things are lowercase. Why is that? What's that?
You don't have to remember to capitalize it.
Not necessarily remembering. The shift is one extra keystroke. So when you think about programmers, they keep things lowercase because it's easier. You don't have to worry about the shift. Any extra keystroke is time when it comes to these programs. So most things are lowercase. All right. When something doesn't work when it should, when you think it should, here's what you should do. Check the spelling first. Did you misspell anything in that line?
Second is capitalization. Did you capitalize something maybe when you read in the data? Did you capitalize something in your actual code itself? And then also check correct symbols, such as the quotes. All right. So I put this quotes thing here is in R. It doesn't matter if it's single or double quotes. As long as if you open with a single, you have to close with a single. If you open with a double, you have to close with a double. But if you copy and paste something from a Word document and paste it into R Markdown, there's a fancy quotes and there's your blah quotes. All right? And those are two different codes on the keyboard. All right? They might function the same. R sees them as different characters. So sometimes if you copy and paste, you say, well, I just copied and pasted it and it should have worked. I may say, go back and replace all of those quotes. So delete and just hit the quote yourself and see if that fixes it. All right? And then the other thing, sometimes you may see in the console window that there's a plus sign that's there. Example. Here they are. Console. All right, so let's do this. Let's. I'm going to do plot of height as a function of weight. Data equals women. And I hit enter. Now I think this should have generated a plot. But note what happens. When I hit enter, I got to a new line. It showed a plus. And that plus is basically saying, okay, I'm waiting on more commands. So then you look at it and you say, okay, well, I typed in command. It should have worked, but R is telling me I didn't finish it. I didn't finish it. So the most common thing that happens is we didn't close a parenthesis someplace. So there's a couple ways to do it. One is just to close it and see if that fixes it, and it does. I get my graph. So over here, it's squished. But expanding it kind of gives us the height and weight graph, right? Or we just X out of it. So I do that. I just, try to hit enter. Something should get us out of that. Can't remember. Let's see. Control. No. Just hit a bunch of numbers and see what happens. You get out of it eventually. Is this going to happen in our Markdown? No. So if we do something like that in the Markdown window itself, in one of these chunks, we should get an error message. And it'll tell us incomplete expression in this case. So it's kind of letting us know that we didn't completely finish it out, and it's telling you what expression was incomplete. So if you had multiple lines in there, hopefully it can at least tell us we've got something wrong. And you'll also notice that the X appears, and that's our studio is basically telling you, I've got a problem with this function here. I've got a problem with this line. Try to go back and correct it. We'll have plenty of errors all throughout the course, so don't worry about it. All right, so what happens if we're running into problems and we need to get help? R has a built-in help package. It gives us information about our functions, and there's a couple ways to do it. So one way is from the console window. So you can do question mark and then the command or question mark and the data frame. These are going to show you the help files right there. It works on my computer in my office. Doesn't really work here very well. Don't know why, but it doesn't. But the alternative is to actually go into the help window that's as part of RStudio and type your command or data there. All right. So for practice, I asked you to view the file for mean and the Dune data set. So there's, as I said, there's a couple ways to do it. One is to actually type it into the console window. So I could do the question mark, mean, and if I run that, I get the help file appearing here. all right? In our R console, it should open up a new page, maybe in your browser, that'll show the actual file. So this shows me, okay, here's my mean function. It's in the base package, all right? What is it? It's the arithmetic mean. All right, the description is a generic function for the trimmed arithmetic mean. All right, and then it gives us a usage. So it's going to be mean and then x. Well, what is x? X down here is an R object. And there are methods for the numeric logical vectors and for date, date time, and time intervals. So x is going to be a vector of some type. It's going to be a numeric vector or a logical vector. So a 0, 1 type of logical vector that can calculate the mean. It can also calculate mean dates. It can calculate a mean date time or mean time interval type data set. So these are specific types of data. What about the dot, dot, dot? Well, it means there's extra stuff that we could give it. So extra stuff that we could give it is we can trim. And we're not going to really talk about trim, but what it does is takes off a certain percentage from the top and the bottom. So if we think we have some outliers at the ends, we can just trim it, cut them out. Or we can na.rm. So if we have missing data, should we remove it first before calculating our means? There will be times where we have to do this, all right? But most of the time, we don't. And then also with the help file, so it gives us the value, what it's going to return, mean, gives us the reference for that function itself. So that function appeared in 1988, the new S language, basically when they described, how to calculate that mean. And then you can see your C also, so weighted dot mean functions. We'll deal with that. And provides an example. So if you are curious about seeing this work, I can copy the example and paste it into the console window. And when I run it, it does this and reports our means. So in this case, we generated a vector 0 to 10, and then the number 50. All right? We calculated the mean of xm. So the mean that we have is 8.75, and then if we trim it and take out the 10%, so 5% top and bottom, I believe, it returns 5.5. So it gives an example. How do we do the Dune package? Well, here's the search up in our help window. So we go to the help tab, and all I have to do is type in Dune, and when I hit enter, it opens up the help pages, and it says it found Dune in 2 different files. It said vegan Dune, so the package vegan. This is Dune, so this is vegetation and environment in Dutch Dune Meadows, and then there's also this Dune.taxon. Well, I didn't ask you Dune.taxon, I asked you for the Dune. So all you have to do then is click on vegan Dune, and this tells you exactly what the data set is. So mean was a function, showed you how to use it. Dune was a data frame, and remember all of those variable names? Yep, they're abbreviated to 4 plus 4 letters, and there are then ways to see it. This help file used to list all of them. So if I go to that make set, I think it gives an example of how to do it. But if you're curious, as part of this Dune data set, they also have a reference. So what you can do is go to this citation, Data Analysis in Community and Landscape Ecology. It's a book. Go to that book, find the book. You'll see the data frame. You'll see how they use that data frame and the code in this data set. So those are the help files. All right. What else can you do? Google. Man, this is R. It's open source. It's free. A lot of universities are using it because it's free. A lot of Fish and Wildlife are using it because it's free. All right. And there's loads of information out there. So if you don't know how to use the mean function, do mean R. All right. And you might have to do mean R statistics to find that information. It's basically type of biostats in most universities, and a lot of them have posted bunch of stuff online, also on YouTube, right? And lastly, don't be afraid to ask for help. All right. So oftentimes, trying to learn the problem on your own, looking it up is some of the best way to learn the material. But occasionally, you will run into problems where it frustrates you up to the point where you want to throw your computer across the room. Don't. All right. Calm down. Ask a friend. Hey, I'm getting this error. Are you getting this error? Or maybe you're at home. Just shoot me an email. All right. The error messages will come. You will get them. All right. I get them. All right. But don't let them stop you. Just take a picture of the error message or copy the error message and say, this is what I'm getting. If you email me, I'll need to know what you were doing. What was the code that you were executing? So you can't just say, hey, I'm getting this error that says incomplete expression, right? Incomplete expression. That doesn't mean anything to me. I need, basically all of this, the code and then the error message. So I can look at the code and say, oh yeah, okay, yeah, you're missing the parentheses. That's all it is. You'll say, really, that's it? Yeah, I'll say, yep. So yeah, email me, stop by my office. It is no problem. We can help you out. All right, so looking ahead, we're going to be doing all of this. All right, you're going to be able to make your own vectors, your data frames. You're going to be able to summarize your data from those vectors. You're going to make tables, figures, and so forth. We'll also do some statistical tests because we're looking for p-values. And you're also learning how to do pretty annotated output. So how do we do that output? So now, hopefully, we have our R Markdown set up. Look at this. All right, I'm going to take out this plot. All right, so now we have our R Markdown made up. All right, how do we make our nice output? Well, I'm going to make sure I save it. And then I am going to knit this document. Now remember, at the very beginning of this, we downloaded that Word template docx file, and I put that reference, I updated that. As long as you save this file in the same folder as this Word template.docx file, all right, it should work. So I'm going to knit to Word. And it's going to process, and this one returns an error. Oh my goodness, what happened? Well, I know it's pretty easy. It's at line 33. So it encountered an error and the process stopped. Well, if you recall, I had this. What happens if an object is not in memory? Right? Just to kind of demonstrate that this fails. Well, I'm going to use that hashtag inside of this R code, and that's going to say, don't execute this command. And then for my annotation, I'm going to say, copy that, and say that if executed, R says, error object Z not found. So that way I have the code. I have everything that's going to happen, and now I'm going to save it, and I'm going to try again. Knit to Word. Let's see if this works. Gets to an output file, output created, and you can't see it, but it opened up Word. And here's our Markdown document. So it opens up the docx file that we just created. It's got your chunks. It's got the output. All right? It's got our name that we gave it, the date. It's got all of the headers set up. So as long as we had that template file in the correct places, it knows what size of font to use for all of the different headers. And you'll see that we do. We have everything here. Including that big Dune data set that I typed in. All right, external referencing data sets. So this is a very nice annotated document. All right, it's got the text that we wrote in there as well as the R chunks, and then it executed everything. So make sure that you can create this document. In what? In phrase? What line number? Did you say?
I changed.
You have word on it?
Did that not work? Did you do library?
Saved it? Don't try to re-save the Word document, that Word template, in the same folder, and try it again. Yours didn't work? Yeah, it's all work? Oh, fine. Yeah. It's L here. And then. Capital correct. I think that's how we get it. Save it, and now try it. Yeah, it's not failing at that. Yeah, that's gonna fail too. Yeah, resave your Word template. Make sure you use the save as. So who has not, so what's your error message?
It says that in eval, parse, text,
Okay, I'm starting to suspect that it is actually due to your Word template. So you're gonna have to right click save as, save the Word as a docx file. All right, and we'll have to check it. So let me, and I'll come over there and help you all out. All right, so what we're gonna do. We have homework. There it is. All right. This is it. Let me make this available. All right, so we've kind of gotten through the R, and there's still going to be a couple more stuff that we've done. What I've done is release the homework, number 1, data in R. All right, so this kind of gets you practice doing the same stuff that we did in class and making our document, or knitting our document. All right, so an important thing about this docx file is that we're going to make it, but this isn't the file that we're going to upload. All right, so we're going to have to upload a PDF file. That way, with the PDF, we can I'm going to be able to annotate it pretty easily. So when you save it, it's already saved. You're just going to have to export to create the PDF and XPS document. All right, and I think this is pretty standard in all the Microsoft Words. And I can provide some limited help for you. But the homework is there. It is set up as homework 01, intro to R. I've got 2 data files, dispersion and statebash.csv. All right. When you open up that RMD file, all right, you will see that it looks similar to this. Similar, it is this. All right. So it's set up as the markdown document. I've got the questions, all right, and what you're going to do is you're going to do what's there. All right. You type in the code in the chunk. You can execute it to make sure it works, and then when you knit the document, it'll execute the code that's in the chunks. All right. So we've got dispersion and so forth. Different steps. This is basically how we're going to set up the exams. All right. You're going to have this Word document. So what I'm going to do is going to go around. If you successfully knitted your documents, you're free to leave. If you wanted to stay and work on this homework, you can. No big deal. But if you didn't, if you're getting error messages, then I'm going to stay around and try to help you until we can get it knitted properly. All right? All right. So that's what I got. Stop the stream.